Chair. My name is Elliot Taylor. I'm the Divisional Director for our office here in Ireland, based in Cork. We now have a team of 7, nearly 8 people here in Cork, covering freshwater marine and terrestrial ecology. Hannah, who will lead on this session and make the presentation, is an Associate Director based in the UK, does a lot of work on hydroecology, particularly on abstractions. We're also joined by 2 other colleagues today, Andrew Davey, who is a Principal Consultant at APEM again in the UK, who has a lot of expertise and experience in hydroecology, and my new colleague, Associate Director Elaine Drummy, who's based here with me in Cork, in Ireland, and who brings in obviously an Irish experience much greater than my own. So she's also joining us today to give us the Irish context. Hannah, if you can just skip to the next slide for me. So yeah, just a bit of a way of introduction of who APEM is. I'm sure many or all of you have probably heard of us already, but just in case you've not, we're a global environmental consulting firm originated in the UK, now with offices fully established here in Cork. In Ireland, we're also working in the US, Australia, we've done work in Vietnam, we're looking at samples from Angola, so we really are a global company. We cover all of the main areas: water, renewables, marines and ports. We have one of the biggest biolabs in Europe, where we can do analysis of marine and freshwater phytoplankton, zooplankton, ichthyoplankton, macroinvertebrates, not chemistry. We work across construction, transport, power and utility sectors as well. Next slide, please, Hannah. Yeah, so we're, as you can see, we're largely UK-centric originally. We started in Manchester and have expanded across the UK. We now have offices in Scotland and Wales, as well as England. I opened the office here in September last year down in Cork. And you may have seen in the social media and announcements that we've made that we acquired Woodrow Sustainable Solutions earlier this year, who are based up in Sligo. So we also have now 2 offices in the Republic of Ireland. So that's just a very brief introduction to APEM, who we are, where we are and what we do. But let's get to the real nitty-gritty, and I'll hand over to my colleague Hannah, who's going to talk to you about assessing abstractions with regards to ecology. So I'll hand over to you, Hannah. Thanks.
Thanks, Elliot. That's great. Brilliant. So thanks everybody for joining us today. I'm Hannah Austin. I'm an Associate Director at APEM, as Elliot's mentioned, and I manage APEM's Hydro-ecology consultancy team. And we oversee a large proportion of our hydroecology work relating to water abstraction. I joined APEM in 2008, and I've got a background in hydrology, modelling and environmental science, and a particular interest in balancing human needs for water abstraction with the water needs of the environment. And building on work undertaken over many years by Dr. David Bradley at APEM, our team has worked on abstraction-related projects for the UK regulatory agencies, most of the UK water companies, and also a number of hydropower studies. And these involve things like literature reviews, synthesis of the hydro-ecological science to try and understand the issues, and making recommendations for how we can better manage abstractions and impoundments, things like undertaking real-world trials, designing and implementing adaptive management plans, monitoring the effects of those, and finding alternative solutions to reducing abstraction. But what's underpinned all of this work is the concept of sustainable abstraction and the question, how much water does a river need? And that's going to be the focus of my talk today. So I'm going to start by running through what sustainable abstraction is and why it matters, look at some of the ways that we assess the impacts of abstraction and how these have developed over time. And then take a brief look at some specific case studies and a quick look at where we might go next and how important that is to meet the challenges that we're likely to face in the future, particularly around water scarcity in a time of a changing climate. So as Elliot said, there'll be time at the end for any questions, and I've invited my colleagues Elaine Drummie and Andy Davey along at the end to get their perspectives into the Q&A session. So please do feel free to use the Q&A to ping us your questions for the end. So what is sustainable abstraction? Well, as a lot of you probably know, in 1987, the UN Brundtland Commission defined sustainability as meeting the needs of the present without compromising the ability of future generations to meet their own needs. And of the UN Sustainable Development Goals, there are three main ones that reference water, and specifically fresh water. And those are number 6, clean water and sanitation, number 14, life below water, and number 15, life on land. And then turning from sustainability to abstraction, in the UK context, the Scottish Environmental Protection Agency, SEPA, defines water abstraction as the removal or diversion of water from the natural water environment, and that can be by any means, so including pumps, pipes, boreholes, wells, etc. So taking these together, we can say that sustainable abstraction is all about balancing our current human water needs with those of the environment and those of future generations. And this nice graphic on the right that I've borrowed from one of the water companies in England illustrates quite nicely all of the competing pressures that there are on the water environment, be that for our immediate needs, such as drinking water, having a shower, flushing the toilet in our homes, the water that farmers need for agriculture and livestock, and what industry needs for example, producing paper or generating power. And what the organisms that live in our freshwater catchments need to live, complete their life cycles and thrive, and then in turn provide us with the natural resources and opportunities, for example, for leisure and recreation. So we've said that abstraction provides essential water for public water supply, agriculture and industry, and then it's also needed by the natural environment to support the ecology and resilience of our rivers, wetlands and aquifers. And then that the natural environment in turn provides us with services that we need and value. So fish, for example, recreation, well-being opportunities. If we don't find the right balance between these needs, then abstraction may become unsustainable, either for us, so we have no more water left for public water supply right now, for the environment. So there's insufficient water in a river, for example, to support its resident populations of fish or macroinvertebrates, or even for future generations. So we have water available right now, but if we keep taking it at the current rate, for example, from an aquifer, will there be sufficient water remaining to meet the needs of future generations? Having the right flow in our rivers and protecting groundwater levels is absolutely essential to supporting a healthy ecology, enhancing natural resilience to drought, and making sure that rivers continue to support not only the environment and ecology, but also our opportunities for well-being, abstraction, drinking water, agriculture, recreation. So sustainable abstraction is all about finding the right balance between these needs. And this can be quite challenging, especially when our need for water is already high and growing. For example, in the UK, we use on average 140 litres of water per person per day, which equates to around about 560 litres per household per day for a household of 4. In the Republic of Ireland, that's estimated to be a bit lower, approximately 86 litres of water per person per day. And I think a lot of this is quite hidden to a lot of people. Think, for example, not only about the water that we use to drink, but also what we use to flush the toilet, have a shower, wash our vegetables, wash our dishes, wash the car. So you might think that we live in a region that's typically thought of as pretty wet. And what does all of this have to do with me? We've got loads of water where I live. And it's certainly tempting to think that as we look out the window on a rainy October morning. Well, across the world, the UN estimate that water scarcity already affects over 40% of the world's population. And even in the UK and Ireland, climate change predictions suggest that we're likely to be heading for, if not already experiencing, drier, hotter summers and warmer, wetter winters with less predictable rainfall. by 2050, the amount of water available for both us and the environment could be reduced by 10 to 15%, projections suggest, with some rivers seeing 50 to 80% less water during the summer months. So we're predicting that in future, perhaps not too distant future, that there'll be less fresh water available for us and the environment, coupled with potentially increased demand and population growth. And if you are at all involved in or interested in water resources, you probably know that this was laid out by Sir James Bevan, Chief Executive of the English Environment Agency, in a conference speech in March 2019 entitled Escaping the Jaws of Death. And he noted that on present projections, many parts of England will face significant water deficits by 2050, particularly in the southeast where much of the UK population lives. So the graphic on the right here is taken from the English National Framework for Water Resources, and the figures that the agency's modelers have generated are quite stark. So they're predicting that if we take no action between 2025 and 2050, around 3,435 million extra litres of water per day will be needed for public water supply. And that includes, for example, over 1,000 million litres a day to make water supplies more resilient to drought, and 720 million litres a day to replace abstractions that are unsustainable and improve the environment. And most of that pressure is in the southeast of England. And similarly in Ireland, I think almost a quarter of the population is concentrated in the Dublin area, and that's led to a variety of options being considered to meet the water needs of the population. So what have we been doing about all of this, and what is still left to do? Well, when I started working at APEM, the narrative was mostly about maintaining low flows, simply making sure that rivers didn't dry out. And then from the mid-2000s and into AMP5 and AMP6, the focus switched to introducing variability across the whole flow regime, as well as looking at alternatives to abstraction reduction at tricky sites. And that's moved on again, and now the focus is on preventing deterioration in WFD status, as well as building resilience, bringing combinations of measures as we realise that we're managing an uncertain situation in a changing climate. And in future, we're likely to need to manage the effects of extreme variability and measures that mitigate not only dry weather, but also flooding. And with this in mind, the recent Water Industry National Environment Programme in England is pushing for longer term and a more holistic approach to addressing environmental impacts. Things like promoting the use of catchment and nature-based solutions, and requiring greater consideration of wider environmental outcomes, thinking about using a natural capital approach and maximising biodiversity. But really, when you take a step back, this all comes back to how best to apportion resources where there's scarcity. So who deserves what and when, compared to our needs, comparing our needs for water against how much water is needed by rivers, wetlands, lakes. So what tools can we use to work that out? Well, the first thing I should say is that there's been a huge amount of amazing research on this globally, particularly in the US, Canada, New Zealand, South Africa, and also in the UK. For us at APEM, the starting point is always scientific literature and evidence. And while I've been at APEM, I've had the privilege to be involved in a number of literature reviews for the UK regulatory agencies and the UK Technical Advisory Group on the Water Framework Directive. And these aim to draw together existing scientific literature to try and conceptualize the linkages between flow, physical habitat, ecology, asking and trying to answer questions such as how much water can you take out of the environment before you start to cause damaging environmental impacts? Does that vary depending on the type of watercourse that you're looking at, the flow percentile, or potentially the time of year? Can you abstract over, say, a very short time period without causing a long-term ecological impact? And can you disentangle the effects of water quality from those of, say, water quantity, quality, or hydromorphology? And if you have an impoundment, say with no downstream flow, is it more important to provide a flow downstream, or do the risks of doing that to water quality and water temperature potentially outweigh the benefits of flow provision? And increasingly, as we've worked through some of these problems, it's been recognised that you can't necessarily solve the flow regime alone in order to generate good ecological outcomes or good ecological status, potential and resilient ecosystems. And so increasingly, the focus is moving towards more collaborative and multi-pronged approaches, making sure that we identify all of the different pressures that are potentially acting on a particular catchment or watercourse, and making sure that whatever we're putting in place to address those will work. So based on all of this scientific knowledge, how do we decide what is a sustainable amount of abstraction? How do we balance our needs with the needs of the environment? Well, in England, the Environment Agency uses the Environmental Flow Indicator, and you might have heard that referred to as the EFI or the EFI. The EFI is used to identify water bodies where reduced river flows might be contributing or causing a failure of good status. And a compliance assessment using that shows where flows are below the FE and indicates by how much. And then that's used to identify areas where flows may not be supporting good status, to target investigations, to check the actual impacts that are happening on ecology and identify what measures are needed to address that. But while the Environment Agency in England does rely on the EFI, it is also acknowledged that it's not necessarily a one-size-fits-all solution. There are some circumstances where there may be better local information that can help drive decision-making. And in fact, there might be some water bodies where good status can be achieved with a flow regime below the FE. However, I would say, and this is really important, that if you're going to deviate from that, obviously you need sufficient evidence to make sure that you and the regulator are very confident in your assessment and that the risk of any future deterioration in ecology as a result of abstraction pressure will definitely be managed. And in fact, there are some really good examples of where use of sort of regional scale hydrology and ecology data have been used to help check that, not only to analyse the past, but also increasingly to try and predict the future. So much so that the Environment Agency now suggests using this type of approach in its guidance documents. And some of my colleagues here at APEM, notably Andy Davey, David Bradley and Dan Cadman, have been at the forefront of developing some of these approaches with the EA in England. And for me, this area of investigation of how we can use data to resolve hydro-ecological problems and maybe even kind of maximise our use of historical data to predict what might happen in future is a really exciting development. And I thought I'd just give you a quick look at some of the outputs from some of these sort of regional modelling approaches. My colleague Andy Davey is planning to cover this subject in a lot more depth, hopefully in a subsequent webinar. So just very briefly, the types of approaches that we've used include pooling data across similar sites to give greater confidence than you can get from, say, analysing data for one site at a time. And also the ability to adjust generic hydro-ecological relationships to reflect some site-specific differences in ecological sensitivity. And it's really useful to do this to go beyond expert judgment in terms of interpretation of ecological data to try and provide quantitative predictions and maybe generating future forecasts under, say, different abstraction scenarios or climate change scenarios. But obviously, as with all modelling, the data that you get out is all about what data you put in. So as well as this type of approach, we've also used other techniques in areas maybe where the data wasn't as robust to use in a modelling approach. We've used things like hydraulic habitat modelling, be that 1D or 2D, alongside things like real life flow trials and analysis of historical data to help us try to establish how much water the environment needs in different catchments. So after all of this effort in trying to identify where the problems are occurring and what effects they're having on ecology and why, what have we actually done as a consequence? Well, overall in England, the Environment Agency reckons that it's made changes to over 270 abstraction licenses since 2008 to try and make abstraction more sustainable. And whilst there's still loads more to be done, for us, I'm really pleased to say that following on from our last rounds of investigations, we've helped implement all sorts of different interventions, and that includes things like adaptive management plans to try and manage reduction of artificially high compensation flows from reservoirs. So monitoring and assessing and making a change and then checking the results to make sure there are no adverse impacts. We've also worked with companies to revise thinking about how and when water should be taken from particular sources and whether that can be done in a slightly smarter way to avoid or minimise environmental damage. At another of our sites, we're into our third year now of spate flow releases from an impoundment to mimic medium-sized high flow events in the late summer and early autumn period. And that's in line with UK TAG guidelines to try and improve the river processes downstream. And we've also seen the benefits of things like installations of fish passes, compensation release and river restoration interventions at other sites as well. So it's all looking very positive. And sometimes as well, we've helped clients develop operational process guides. So perhaps where the potential risk, it's very unlikely, say, that abstraction would need to occur under very low flow conditions. But if it were needed without any monitoring or mitigation, there is a big risk to the environment. We've helped develop operational process guides so that the client and the regulator can be confident that the intervention can be put in place without harming the environment, and that monitoring is in place as well to check that our assumptions are correct, even under the very lowest flow conditions. And I think that brings me on quite nicely to my next point, which is about alternatives to abstraction reduction. So what happens if you don't have the option to reduce abstraction in order to, say, meet good status or good potential? So we've seen some cases where changing abstraction licenses is the primary method to resolving an unsustainable abstraction, and that's great if it's possible, but it's not always possible if there's a particular issue around local demand for water. So it's increasingly recognised that it's unlikely that we can deal with all of our problems by just reducing abstraction. So what do we do in those cases? So as an alternative, we've looked at things such as implementing habitat restoration within the river channel or within the catchment alongside the licence changes to try and develop a more resilient ecosystem and enhance the benefits of increasing the amounts of water in our rivers. And where ecological problems are caused by a combination of issues, it's increasingly recognised that other solutions are going to be required to improve ecological status as well. Also, that wider benefits on the catchment scale will take time to realise, but if you do introduce effective combinations of measures, then the water bodies supporting a healthy ecology can be expected to increase. So these are just a couple of examples where the best approach to ecological improvement was deemed to be things like fish passage improvements and physical restoration measures in combination with abstraction reduction, as well as where potentially if you've got an issue not only with abstraction but poor water quality, you can reduce the pressure overall by, say, putting in place catchment measures such as fencing to reduce fine sediment ingress in combination with abstraction reduction to get an even better outcome. So what have we learned over all of these years of trying to balance the needs of communities, the economy and the environment? Well, firstly, I would say don't just focus on one aspect of the flow regime, and also don't just focus on the flow regime alone. Think about how the hydrology, geomorphology and water quality of your catchment are all interacting together and how multiple pressures might be affecting the ecology. Definitely understanding which pressures acting on your watercourse can help you to understand what measures you might want to put in place to tackle those. probably also where, and maybe even in what order. So if you haven't got a huge amount of money to throw at the problem to start with, what are the most important things to address first and what can wait until later? I think that's particularly important in situations where funding is restricted or timescales are restricted and you can't do everything that you would potentially want to do all in one go. Second, I would say base your decisions on local data and knowledge and evidence wherever you can. And you could try and think outside the box with that one a little bit as well. So how can you make the best use of the data that you do have to get the answers that you need? If you've not got a huge amount of data, can you borrow power from a regional data set to give you some additional confidence in your local data set? Can you look at data from another nearby catchment? And can you engage your local stakeholders as well and work collaboratively with them where you can? We've seen some really, really great outcomes from that type of approach. Third, when you make a change, don't expect an immediate response from the ecology and be prepared that you might need to tweak your plan slightly to get the outcome that you want. So make sure that you're monitoring whatever changes you're putting in place. And finally, try to think long term. It's really encouraging that this is now being recommended by the regulatory agencies more and more. So could you get longer term benefits or added value in terms of biodiversity or management of flood risk, say, by thinking about things in a slightly different way? And I think that's where natural capital, catchment-based approaches and thinking about biodiversity can really, really add value. So what's next in addressing the ecological impacts of abstraction and impoundment? Well, I think the challenge of balancing increasing water scarcity driven by climate change with population growth, going back to the jaws of death quote I mentioned earlier. In England now, we're starting to think about our 2050 environmental destination in response to the national framework and working collaboratively in regional groups to try and deliver big schemes and multiple benefits for the environment, whilst also meeting the needs of industry and society. On a more positive note, our scientific understanding of the effects of abstraction and impoundment on ecology is improving all the time. And the statistical tools and processing power that we have to analyse big data sets is also improving. Which is great, as is our ability to rapidly react to change through the use of things like automated systems. And I've obviously had quite a lot of experience of dealing with some of these issues in the UK context. And as Elliot mentioned earlier, it sounds like the island of Ireland is at the start of that same process of getting to grips with balancing the needs of people and the environment in terms of water abstraction. And I'd be really interested to hear from anyone in the audience in the Q&A session in terms of what challenges you're currently facing. So I thought I would leave you with a final thought. We know that water scarcity is likely to become an increasing problem. What can we do to make a difference? And here are a few suggestions from WaterWise about things that we can all do to reduce our demand for water so that there's more left to go around and we can enjoy it in the environment as well as the benefits it gives us coming out of our taps. So that's it from me. Thank you very much, and I'll hand you back to Elliot for the Q&A.
Great, thanks very much, Hannah. That was certainly really useful and interesting from my point of view. It's good to be reminded of many of those things. Yeah, I mean, your last point there, I think, is really important as well, and that's just the need to remind people of the value of water and just how every little bit of it that we use will make a huge difference ultimately, because each of those little bits adds up to a lot.
Absolutely.
So we've got a couple of, well, we've got one question in the Q&A. So I'll put that one to you first, and then I'll ask people if they want to unmute and ask questions. This comes from Mark Tinsdale. APEM rightly promotes a very science and evidence-led approach, but what is your view on how citizen science or local knowledge can be incorporated into the problem definition solution process?
I think it's going to be absolutely essential going forward, personally. And interestingly, we've worked, although we do want to be led by the evidence and by the science, that can come from a variety of sources, and citizen science is definitely one of those. In fact, we've had really good outcomes of studies where we've combined not only sort of data that's maybe been collected in a traditional way, and not even necessarily sort of citizen science, but local knowledge of sites as well, I think is really important. I think that that's something we sometimes lose sight of in sort of the water consultancy industry, that you really need to make best use of people who are in these catchments on a day-to-day basis and understand how they operate.
Thanks. I mean, certainly from my experience, I've worked a lot in Southern Africa, and again, I think Southern Africa, particularly South Africa, has really led the way in this kind of discussion. And again, they went on a similar trajectory that you set out there, going from just looking at low flows to what were called environmental flows, and now they use what are called as integrated flow assessments, and that's social and technical and ecological aspects all drawn together to make decisions about the amount of water that can be left in the environment and the amount that can be used for other things. So there's another question has come into the Q&A from Brian Coughlin. If abstraction cannot be reduced, what restoration techniques would you enact in a river corridor?
Well, it probably depends on the site, but the aim is probably, if you've got a limited amount of water available, you can't reduce abstraction, how do you make the river as diverse as possible? How do you make the water quality as good as possible? How do you make the ecology as resilient as possible? So things like adding refuge areas, improving the structure, variability of the river channel, and making sure that you're not exacerbating any low flow problems with unnecessary inputs of pollutants. Trying to reduce those as much as you possibly can will help.
Yeah, sorry, Andy, go ahead, please.
Yeah, hi everyone. Just to add to what Hannah was saying there's some evidence emerging from some of the hydroecology modelling work that Hannah was mentioning that makes it very clear how morphological alterations of river channels make them much less resilient to low flows. The mechanism there is almost certainly linked back to a degree of habitat diversity. A more diverse channel with a greater variety of mesohabitats provides refugia for a range of organisms during those low flow events. Other work that we've done for companies such as Severn Trent Water, for example, has also shown how fine sediment inputs interact with low flows to have a sustained long-term impact on macroinvertebrate communities. So anything we can do to try and tackle some of those sources of fine sediment within the catchment, whether that's through better soil management or putting in riparian buffer strips as well to try to intercept some of those pollutant pathways, can also help to reduce the impact that low flow events might have on those aquatic systems.
Thanks, Andy. So there's another question coming from Lorraine Gaston. So is EFI used, or can it be used for heavily modified water bodies?
We have a slightly different approach to tackling heavily modified water bodies. So you could, but if we think about impoundments, for example, we're probably more looking at the UK TAG guidelines on releases from impoundments, and that's where some of the stuff that I was talking about in terms of adaptive management plans and spate releases has come from. So similar to what Elliot was just mentioning about not only looking at low flows, but downstream of impoundments where you might have like a very elevated compensation flow, so sort of artificially elevated low flows, and potentially an absence at certain times of year of particular spate flows where anything that's coming down from upstream is getting swallowed up by your impoundment, to try and make changes to the flow regime to make the regime mimic something that would be expected naturally.
Thanks, Hannah. So there are no other questions in the Q&A function. So does anybody want to unmute and ask a question live? Don't be shy. So what are the main issues you're dealing with at the moment, Hannah? Who are we working for, and what are the issues that they're asking us to help them with?
I think probably, and Andy, do chip in if I miss any, but probably the main two I would say are managing the risks of deterioration in WFD status. So historically, a lot of the work that we've done has been looking at the impacts that are already occurring of abstractions that have been happening historically for a period of time. Whereas now the water companies that we're working with in England are looking more at, okay, well, we've hopefully resolved a lot of the problems with historical and ongoing abstractions, but we're predicting population growth, we're predicting increased demand for water. So how do we manage that? Because if we abstract more water, then potentially we have adverse effects on the flows in our rivers. So how do we, it's what I was saying before about sort of going from analysing the past to predicting the future. So how do we manage that future risk of potential increases in abstraction? How do we know, how do we sort of understand that kind of chain of causation from the abstraction to the change in flow to how that might impact ecology and how that might affect WFD status? It's quite a long chain to work through to try and understand what the potential risks might be. And that's where some of the monitoring and modelling approaches that Andy's been developing, I think, are really going to help. And then the other main one is around the response to the National Framework for Water Resources as well, and looking at environmental destination for 2050. So what have we currently got in place in terms of abstraction reduction? What abstraction alternatives to abstraction reduction do we have? How can we work better with other stakeholders within the catchment to better balance abstractions of different types and make sure that everybody has access to the water that they need? How do we think about potentially reducing people's demand for water, making people aware that maybe it might be better to use slightly less? How do we make our systems more resilient to drought? All of those kinds of challenges.
That's right, Hannah. And just to elaborate on that a little bit, I think there's a lot of focus now, certainly within England, which is being promoted by the regulators to take a much longer term view. Historically, water companies have been very focused on short-term solutions, and that's been driven by a 5-year funding cycle, which is fine for addressing perhaps individual issues on a site-by-site basis, but increasingly there's a recognition that we need to think a lot more broadly about how we manage water resources over a much larger spatial area, whether that's a broader catchment area or increasingly at a regional level. We've now got 5 regional water resources groups across England and Wales, which are taking a much more strategic view about how we use water. So some of the implications of that are a greater push to try and join up different parts of water company strategic plans. So up to now, we've had separate focuses on water resources. We've got a water resources management plan. We've got new drainage and wastewater management plans, which deal with wastewater discharges, making sure we've got sufficient capacity in the system to manage future growth in that area. And also then linking it into more catchment-based approaches, which to date have tended to focus on finding solutions to drinking water quality issues, where we've got issues with nitrates or phosphates or algae and taste and odour, and trying to bring all of those together. But of course, when you're trying to take a more sort of catchment or nature-based approach, that inevitably takes longer. It's a more complex problem. You have to bring more evidence together and also involve a much wider range of stakeholders as well. So going forwards, I think water companies are going to be encouraged to look beyond just a 5-year planning cycle. And when they'll be submitting their next business plans in 2024, they will be agreeing with the regulators a programme of environmental improvements for the next 5 years, but with an indicative programme of improvements for a further 5 years beyond that, and then also some longer term environmental ambitions beyond that as well. So it's recognising that to solve some of these longer term issues takes longer term planning and longer term investment, but it's encouraging to see that that's now the direction that that regulators and water companies are moving together in.
Yeah, I don't know about you, Andy, but I definitely think that although it's really challenging, it's also a really positive time as well. in terms of getting to grips with some of these problems, and rather than just kind of throwing concrete at things, trying to come up with something that's a more holistic solution for whole catchments or regions.
We've got 3 more questions that have come in whilst we've been discussing this. So the first one, and certainly an issue I've dealt with before, about a paucity of ecological data around pressure sites, and how long would we want baseline ecological data collection to be in place before assessing and designing a response?
Oh, that's a good question.
Yeah.
As long as possible.
Yeah.
But I think, Andy, I don't know whether you kind of want to comment on that at all, but that's where some of the stuff that you've been working on in terms of, particularly with the Environment Agency as well, in terms of trying to sort of borrow data from different catchments, borrow power from different catchments, can really be quite helpful, as well as things like local knowledge that we were talking about before.
That's right. I mean, I think we would always like to have slightly more data than we often do.
So true.
And clearly, when you look at problems on a site-by-site basis, you have, if you're lucky, you might have data, extending back maybe 5 years or 10 years if you're lucky, and ideally that would span a sort of a range of wetter and drier years. So you can see from that how different ecological metrics perhaps respond to natural hydrological variability. But increasingly, we're trying to scale up a little bit. So recognizing that limited amount of data can sometimes give you either less clear-cut, robust results, or sometimes slightly misleading results. And by drawing data together from a range of sites, which maybe span a gradient of abstraction pressure, so some sites which are relatively pristine, others which are much heavily modified, we get a much better understanding about where our sites of interest fit on that spectrum. And by making comparisons across sites, that gives us a firmer basis for judging exactly how impacted a site may be, and also how abstraction and low flow pressures, for example, interact with other morphological or water quality issues as well. One of the benefits of a hydroecology modelling approach is if we can calibrate a model which defines a relationship between the ecology and flows, then in theory we can extrapolate that model and start to make predictions for locations even where we don't have any historical monitoring data. And that in turn allows us then to have a better understanding about the spatial distribution of impacts within a catchment.
Yeah,
I guess
that's very true, because we often don't have data in the right place as well, apart from not having sort of a long enough timescale of data, or not as long as we would ideally like.
So there's a related question as well from Patrick Morrissey. Could you elaborate on the data needed to populate site-specific models? And also, how do you assess the output of these models when baseline conditions are not known for existing abstractions?
So I think we often can't be too fussy about the data that goes into these models, but ideally we would want information from sites which, say, span a variety of conditions. So we're able to sort of compare and contrast sites which are subject to different levels of abstraction pressure. Using the sort of statistical modelling techniques that we can apply to this data, we can judge the degree of confidence in those relationships. You don't always get as clear-cut relationship as you might like, so sometimes things can be quite complex and a bit more messy and uncertain than we would ideally like. But at least we can quantify that degree of uncertainty, which is perhaps, allows us to go slightly beyond what we can do with expert judgment alone, where we're relying on the sort of, combined knowledge of individuals or groups of experts to try and define a degree of certainty. We can quantify how certain we are, and also potentially use that to then guide further data collection, so we can anticipate what the benefits would be of collecting further samples at existing locations versus the benefits of branching out and perhaps sampling other locations that haven't been subject to monitoring in the past.
So, but I think he's also asking about, what specifically the kind of data that we need. So, I mean, I guess information on flow, what is it, macroinvertebrates, macrophytes, fish, channel structure. What is it that we need and we look for ideally to put together to make a decision on a site-specific basis?
So in terms of the ecology data, it very much depends on what receptors we believe are likely to be most sensitive to abstraction in a particular type of river system. A lot of the work we've done has tended to focus on macroinvertebrates because they are fairly widely monitored, and also we're able to collapse that data into some well-established community level metrics, which we know from previous research correlate and respond well to patterns of flow variability. But there's no reason why these models have to be restricted to macroinvertebrates, and we've done other modelling for the Environment Agency, for example, which has developed equivalent models for diatoms. We are currently doing some work for salinity water, which is looking at how macrophytes respond to antecedent flow conditions. And similarly, we've done various modelling studies for water companies and regulators, looking at how densities of salmonids and how recruitment into those fish populations also is influenced by patterns of flow. So the ecology data can take various different forms. The flow data, ideally, we would have a time series of ideally daily, or if not monthly, flows at each ecological monitoring site. So often that involves either extrapolating data from nearby gauging stations and using local spot gaugings to help validate that flow time series. And where we're dealing with abstraction impacts associated with groundwater, we can draw on existing groundwater models, which are a very useful tool because they allow us to produce a historical time series for any particular point along a river network, which we can then link up with specific ecology monitoring sites. Those groundwater models also have the advantage that we can run various scenarios through those models. So we can look at historical flows. We can also generate a time series of naturalized flows by adjusting for any abstractions and discharges within the catchments. And then we can also run various future scenarios to explore those patterns of population growth and demand for water, also potentially factoring climate change impacts as well. So those are the two core building blocks. We need ecology data collected from a number of sites using standardized protocols, and we need some measure of historical flows, either from a groundwater model or from gauging stations. And then if we can supplement that with any other sort of measures of morphological alteration, and we've used information from river habitat survey, for example, and other spatial data sets which provide a high level indication of the naturalness of a channel, then that potentially allows us to then sort of tease out some of those interactions between different pressures.
Great, thanks, Andy. I think you have answered Tim Johns' question in your answer there, but he was saying, how is changing climate factored into the modelling of future flow regimes together with likely increased population growth? I think you covered those areas.
So certainly in the EA's national framework, climate change has been built into some of the future scenarios to identify where deficits of supply are likely to occur. And groundwater models and surface water hydrological models certainly have the capability to incorporate things like UK CP18 climate change scenarios into that, if we want to take a sort of a longer term look and try to forecast how the ecology might respond under different climate change outcomes.
Right. And a couple more very interesting questions that have come in now. The first one from Finley Horn. So looking forward, will hydro-ecological modelling take over from simply assessing derivation from natural flows, or is there a need for both types of assessment?
I don't think there's necessarily a dichotomy there, because there's various different ways of structuring a hydro-ecological model. One is to link the ecology back to the flow regime that's been observed in previous years. Another is to link it directly back to measures of deviation from natural flows. So you can actually measure the effects of abstraction pressure directly. I don't think we see hydro-ecological modelling as being the panacea. It does require a certain amount of data to build and calibrate these models. More often than not, it's an additional line of evidence that goes alongside some of those other techniques that Hannah mentioned in her presentation, albeit one that can give us a set of tools that allow us to make quantitative predictions into the future much more easily, perhaps, than we can with some of the existing tools.
Yeah, I think that's a really important point. We're always we never have enough evidence or data, so we're always trying to build up that weight of evidence using all of the tools that we have available, whatever they may be.
And I think that comes back to the point that you were making as well, Hannah, is that it's not just flow or water quality or ecology or hydromorphology. It is the interaction of all of those things together. And just because you have one bit right doesn't mean that the rest will be. I mean, you know, very simplistically, I always used to talk about beautifully clean water flowing down a canalized concrete channel. That doesn't really deliver what we're looking for, certainly under WFD.
No.
So there's one more question here from Chris McGregor. Have you any experience of abstractions being used against future ability to deliver river restoration projects?
Might need a little bit of elaboration on that one. So do you mean people being restricted in the amount they can abstract in order to protect the sort of viability of a future restoration scheme?
Chris, do you want to come on off mute and elaborate?
Yeah, can you hear me all right?
Yeah?
Yes.
Okay. Yeah, sorry, I was trying to work it out in my own head as well, really, what I was asking, so sorry about that. It's more around, we've got I work for Natural England in Yorkshire, and we've got it's a current licensed abstraction, but it hasn't actually been enacted for about 20 years. And Yorkshire Water are looking to reenact it, effectively move their current abstraction to leapfrog some water quality issues in another tributary, and that's a whole different kettle of fish in terms of addressing, which I won't go into. But one of the things that, so it's a SSI river, not SAC, SSI river, and one of the things that trying to get across is that in its lower reaches it is a heavily modified section, but some of the geomorphological assessments are kind of almost looking at the channel as it is now rather than what it could be if elements of the river restoration plan, which may be medium to longer term, are enacted. And so in terms of the designated site driver, as it were, you know, we've got the conservation objectives, we've got elements in that around the river maximizing as much in terms of its natural ability to interact with the floodplain, taking natural processes as the start point, but just seems to be a bit grey in terms of how, I mean, to be fair to Yorkshire Water, they're taking a lot of that on board, but how far that can be pushed in terms of sort of saying, you know, restoring flow regimes is one thing, but within the context of what the river's doing at the moment, not what it potentially could be doing in 10 years' time if we can deliver X, Y, and Z.
Yeah, I think,
sorry.
No, that's useful. I think that's a challenge that is coming up more and more, even with things like sort of designing revised flow regimes and making sure that they work with existing or planned fish passage interventions and all that kind of stuff. And I think that's where some of the things that Andy's been mentioning about that kind of longer term view, a more catchment-based, nature-based solutions type approach can help, and adaptive management as well. So I think we need to move away from thinking, right, okay, well, we've sort of put these things in place and solved that now, and we need to be thinking more holistically and longer term about, right, okay, well, this is fine for now, but if something else changes in future, we might need to revisit that and make some further tweaks in order to maximize ecological potential. So perhaps thinking sort of slightly longer term, and perhaps thinking in an adaptive management framework or like a staged process might assist with some of that. So is there something that you could do now and then revisit that, say, in 5 or 10 years' time?
Great, thank you.